In this video, we're going to look at how to evaluate things with rational exponents. And rational exponents are basically exponents that are fractions. As we know, ratio in math means fraction. Like rational expressions are basically fractions made up of polynomials. And rational exponents are just fractions as well. So first we want to look at what a rational exponent means, or what its parts mean. So if something is raised to an exponent that is a fraction, this top number will be the power that we're going to raise the base to, and the bottom number will be the root that we are going to take of the number. All right, so for example then, if we have something written like this with a rational exponent, we can rewrite it in radical form by taking the bottom number and making it the root, the nth root of this base raised to this power. So again, the bottom number is the root, the top number is the power. Okay, so you can do it like that, where you raise the number to the power and then take the root of it, or you can take the root of the number and then raise it to the power. Either of those is acceptable. So this is going to make more sense when I put a number in there. Okay, so let's look at one with numbers. 8 to the 2/3 power. Okay, so again, we can do this, which would be the cube root of 8 squared. Okay, so we would square the 8 first and get 64, and then take the cube root of that, which would be 4. Okay, or we can do the cube root of 8, get that answer, and then square it. It doesn't matter which order you go in. The cube root of 8 is 2, and then 2 squared is 4. Now, if you're not using a calculator, then I recommend that you do it this way, where you do the root first and then the power. If you do it this way, the numbers don't get as big and they're just easier to work with. So root first and then power. All right, so if we had like 100 raised to the 5/2, let's do the root first. The bottom number is a 2, so that indicates a square root, and then we'll raise it to the 5th power. The square root of 100 is 10, and then 10 to the 5th power is going to be a 1 with 5 zeros. That's the easy way to do 10 to a power. This tells you how many zeros to put after your 1. So 10 to the 5th power is 100,000. All right, or 81 to the 1/4. Again, if we take the bottom number and do the root first, the 4th root of 81, and then raise it to the 1st power. The 4th root of 81 is 3. Raised to the 1st power would be 3. All right, let's do one more. 25 to the 3/2. Bottom number's the root, top number's the power. A 2 is a square root, so square root of 25, then raise it to the 3rd power. The square root of 25 is 5. 5 to the 3rd power is 5 times 5 times 5. That's 125. Okay, what about a negative? Now, we have to be really careful when we have negatives. We can have some problems that look very similar, but they are not the same. So I want to compare these two things here. Negative 27 in parentheses raised to the 1/3 power. And I'm going to work that, and I'm going to work this and show you how they're different. Okay. All right, so if this is in parentheses, then we're dealing with this whole thing, negative 27. we're going to take the cube root of it because it's got a 3 on the bottom, and then we're going to raise it to the first power. So we have the cube root of negative 27, and then we're going to raise it to the first power. So the cube root, we can do a cube root of a negative because it's an odd root. Cube root of negative 27 is negative 3, and to the first power would be negative 3. Now, if you have this negative out front like this, I want you to kind of think of it like this, as negative 1 times 27 to the 1/3 power. Because this negative is not getting raised to the 1/3 power, just the 27 is. So I sometimes just bump that out front and put it like it's a negative 1 out front, and we'll do that last. And so negative 1 times 27 to the 1/3 power. That would be the cube root of 27 raised to the first power. Well, the cube root of 27 raised to the first power would be 3 to the first power, which is 3. And that ends up getting multiplied by this negative 1, and we get negative 3. Now look, we got the same answer, but not for the same reason. And I want to show you why it's important to know that. Because what if I have negative 16 raised to the 1/2 versus negative 16 to the 1/2 with no parentheses? All right, here again, this whole thing is being raised to this power. So we keep the negative with the 16. We're going to do the square root of negative 16 to the first power. Well, right there, we get stopped in our tracks because we can't take the square root of a negative number and get a real number answer. So we can't work this any further. And for right now, we're just going to say not a real number. Now let's see about this one. If we have this negative is not attached to this 16, we can bump it out to the front like this. Let's work 16 to the 1/2 power. That's going to be the square root of 16 to the first power. So 4 to the first power is 4. And then we're going to multiply it by this negative 1. And so we end up getting negative 4. So this one has an answer and this one does not. So that's why it's super important to know the difference between those two things. All right, let's just do a few more. How about 1/25 raised to the 3/2 power? Okay, again, the bottom number is the root, the top number is the power. You can do it in either order, but we're going to do the root first and then the power to keep our numbers from getting too big. So the bottom number is a 2. That tells us we're going to take the square root. And then once we take the square root, we're going to raise our answer that we got to the 3rd power. So the square root of 1/25, the square root of 1 is 1, the square root of 25 is 5. Then we're going to raise this to the 3rd power. When you raise a fraction to a power, you just do the top to the power and the bottom to the power. 1 cubed is 1, and 5 cubed is 125. So that's our answer. All right, how about 1/27 to the 4/3 power? All right, again, the bottom number is the root, the top number is the power. Let's do the root first. So the cube root of 1/27, and then when we get that answer, we're going to raise it to the 4th power. So the cube root of 1 is 1, and the cube root of 27 is 3. And now we're going to raise that to the 4th power. So we're going to have 1 to the 4th power is 1. And 3 to the 4th power, if you don't remember, we did this, but we'll do it again. 9 times 9. So 3 to the 4th power is 81. So our answer there is 1/81. Okay. Now, what if we have a negative fraction exponent. Okay, there's two ways we can handle this, so I want to show you both ways. The first way, some of you may say, well, we can't have a negative exponent, so I want to fix that first, and that's fine. You can fix that first if you want to, and we would fix that by moving this to the bottom of the fraction, and by moving it to the bottom, that exponent would become positive. And then we can go from there and we can try to evaluate this denominator here. And we would do that by taking the bottom number, that's the root, so square root of 4, and then raising that to the third power. Okay, so the square root of 4 is 2, and 2 to the third power is 8. So that gives us 1/8. Now, we could also go right to the fraction exponent and rewrite it in radical form. That means with roots and powers instead of fractional exponents. So the bottom number would be the root, so we would take the square root of 4, and then we would raise it to the negative third power. So the square root of 4 is 2, 2 to the negative 3. Then we'd fix the negative by moving that to the bottom, and then we would evaluate that, and you see we still get 1/8. So it doesn't matter what order you go in there. The two things that have to be done are you have to get rid of the negative exponent and you have to evaluate the rational exponent. So whatever order you go in is fine. Let's do another one like that just to make sure we got it. 32 to the negative 4/5. I'm going to do this one both ways as well. If we want to fix our negative exponent first, we would move that whole thing to the bottom, and that would make our exponent positive. And then we would need to evaluate this by putting it in radical form. And so the bottom number is the root, so 5th root of 32, and then we'll raise it to the 4th power. So the 5th root of 32 is 2, and 2 to the 4th power is 16. Alright, so we got 1/16 on this one. Let's show it the other way as well. When we do it the other way, we're taking care of the fractional exponent first by rewriting it in radical form. So the bottom number would be the root, so the 5th root of 32. The top number would be the power, so negative 4. The 5th root of 32 is 2. 2 raised to the negative 4, well, we can't have a negative exponent, so we're going to fix it now by moving that to the bottom of the fraction, and that'll make our exponent positive. And then we end up with 1/16, which is what we had right there as well. Alright, so we need to be able to convert things back and forth. So I'm going to just do a couple examples like that to make sure you understand what this is asking you for. If your instructions say write using rational exponents, so you need to be familiar with this vocabulary. Rational means fractional. So if they give you a radical like this and want you to write using rational exponents, you have to take this and rewrite it with a fraction exponent. So it's going to have a base of x, okay? The bottom of the fraction will be what root you see right here, and the top will be the power. Well, if you don't see a power right here, that's an understood 1. So that's going to be a 1 right there. So this is equal to x to the 1/3 power. Let's try another one. If we have the 5th root of y squared, how can we rewrite that using fractional exponents? The base will be y. The bottom of the fraction will be the root here, so a 5. And the top of the fraction will be the power that the y is raised to, so a 2. So that'll be y to the 2/5. Okay, what about the 4th root of ab cubed? All right, we'll do each letter individually. A has got a root of 4 and an understood power of 1. So that would be a to the 1/4. B also has a root of 4, but it's got a power of 3. So that would be a to the 1/4, b to the 3/4. 10 square roots of b. All right, the 10, if you notice, it's not under a root, so we do not have to convert it. We can just bring the 10 over. The b is what we have to convert. The b is being raised to the first power, and we're taking the square roots, the 1 on top and a 2 on bottom. So b to the 1/2. All right, and let's do one more. -2 cube root of x. Again, the -2 is good. It's not under a radical, so we don't have to convert it. We'll just bring -2 over. It's this cube root of x we have to convert. All right, so it's going to be x to the, since it's cube root, that's a 3 on bottom, raised to the understood first power, that's a 1 on top. All right, we got to be able to go the other way as well. So if your directions say express in radical notation, radicals are roots. So you need to be able to take something with a fractional exponent and rewrite it with roots. So if you have x to the 2/3, that's a fractional exponent. We can rewrite that with the bottom number as our root and the top number as our power. So it can look like this is acceptable, or this. Okay, either one of those is fine because the order that you do it in doesn't matter. Okay, let's do another one. 6y to the 3/4. Now again, the 6 is not being raised to a fractional exponent, so it doesn't need converting. It's just going to stay a 6. It's this y to the 3/4 that we need to rewrite, and we can rewrite that as the 4th root of y to the 3rd. Okay, or if you like this way better, the 4th root of y to the 3rd. Okay. All right, just a couple more. X to the 3/4, y to the 1/4. All right, now we've got both things with fractional exponents, so they both have to be converted. You can see they both have a 4 on the bottom, so that's going to be a 4th root. So if you want to do them together, you can and put them under one big 4th root. And this would be x to the 3rd power and y to the 1st power. Now, if you didn't realize that and you did them separately, that would be okay as well. Okay, so either one of those would be fine. This is probably the better way, but I would accept this as well. And let's do one more. 5r to the -2/3. All right, let's see. You know, we don't want a negative exponent, and we also want to put this in radical notation. So let's fix the negative exponent first. Now, please make sure you realize this negative exponent is only on the r. So leave the 5 alone. It's going to stay on top. This is going to be r to the 2/3 on the bottom, and then we'll convert that to the cube root of r squared.